Well, good afternoon, everybody. This is Gene Bohensky at IR Thermal Systems and Anderson Thermal Devices. This afternoon's presentation is called All About Infrared Lamps, Integration into Products and Systems. We'll also be talking about how to select lamps for your application. So as an introduction, let's just say a few words about our company. We were founded in 2020 after the former management team purchased the assets and intellectual property of Radiant Energy Systems and Anderson Thermal Devices. So the management team and most of our staff and employees have had experience since 1985. So we have a long history of understanding of the market and products. So Anderson Thermal Devices is a New Jersey-based manufacturer of infrared lamps, infrared replacement lamps, and shortwave IR emitters and components. We have over 75 plus years of experience in infrared heaters and components, and we can help you find the right solution for your application. We offer a broad line of shortwave, medium wave, twin tube, and panel heaters. So we have a wide range of lamps available. We have shortwave IR emitters, including T3 lamps and T4 lamps, medium wave lamps, twin tube IR emitters, infrared panel heaters, custom shaped lamps, and replacement lamps. So here are some of our custom lamps available. We have C-type lamps, Omega lamps, and round custom lamps like that on the right. A little bit more about how our company does business. We're really set up for large volume manufacturing, and the way we process orders is just in time. And so we're set up to do either small or large orders in a just-in-time process with short lead times. In general, we have lower pricing.
How do you feel about your appointments being cancelled?
And we have both standard and custom lamp configurations. And we have crossovers to common lamps from Ushio, Heraeus, Philips, and other manufacturers. So basically, if you have a lamp that you're currently using now, we can cross that lamp over, and we can also customize a lamp that is specific to your application, whether you're trying to build it into an oven or build it into a product that you're making, or any kind of other application where you need an infrared lamp. So industries that we serve include converting, paper, film, and foil, printing, non-wovens, plastics, adhesive lamination, batteries, medical devices, filter media, powder coating, that's a big one for lamps, PET bottles, fiberglass, advanced composites, industrial fabrics, automotive, packaging, wire and cable, textiles, and many others. So how do you determine which infrared lamp fits your application? Well, first we start with what material is going through the heater or dryer. We need to understand the ideal temperature the substrate needs to reach. That's the application temperature. The dwell time required, that is how long that material has to stay heated. The absorption coefficient of the substrate, that includes the color, material, and the surface properties, and the size of the equipment and area where the lamps will be installed. So we have an application engineering department that helps our customers select a lamp if they don't know what is ideal for their application. With some of these variables, we can help choose the right lamp. So if you already know a lamp, there's also a way to specify your lamps with the wattage and the voltage, the heated length and the overall length. So the heated length is the part that is actually doing the heating. That's where the element is located in the tube, and the overall length of the entire lamp itself. We also need to specify the connection ends, the lead type and length, whether it's a bare wire, PTFE coated, or other. A reflective coating, ceramic, gold, or none, whether there's ruby colored quartz requirement, that's for cutting glare, or any other construction details. And of course, we also can work off a part number that you can supply from a competitive unit. See in this picture on the right, you could see some of the different versions that are available from clear quartz elements. This one here is a gold plated, and here's the ruby colored, and here's some of the different connection ends as well. So depending on what you have for your application, we can build it. So basically, when you're looking at heaters, the application is really based upon the temperature determines the wavelength. And typically, most lamps fall into the short wave area. That's the red graph here. There's also medium wave emitters. Some of those are lamps, and some of those are some of the metal elements we make. And there's also long wave emitters, and we don't really get involved too much in that marketplace. You also choose your wavelength based on the application that you're using. You look at the absorption factor of water film thickness there, graph on the left, and on the right we have one on PVC sheet thickness. And you could see that based upon your absorption factor and your wavelength, you have different. You can select the different wavelengths accordingly for the material. Here's a couple pictures of lamps in operation. On the left, there's a medium wave lamps, and you can see the metal part. This is a powder coating operation with this long part here going through this oven. On the right, you have shortwave infrared for metal coatings. And shortwave is typically used because it's very hot and good for powder coating on metal. It's a little bit more about shortwave lamps. So our ATD shortwave IR emitters include T3 lamps and T4 lamps. They utilize a low mass tungsten filament to provide a high temperature source that responds easily to voltage changes. That allows for precise control during your industrial infrared heating process, as well as infinite turndown. All of the lamps are hermetically sealed and filled with an inert halogen gas, which helps prolong the life of the filament. They're available with a white, ceramic, or gold reflector coating on the back of the lamp to make them unidirectional. We also offer non-glare, ruby red, Helen coatings, and satin-coated quartz lamps that are available for filtering out most of the high-intensity visible light. There's some of the shortwave lamp end connections that are available. Those are the most common ones that we have available. So let's turn on this video that shows the lamps in action.
Now we're going to demonstrate shortwave infrared heater. It's in the 1.5 to 3 micron range. It's a quite intense heat. There's in a small package. This particular unit has some air holes for aiding in the heating process, breaking up vapor barrier, and the lamp itself is made of tungsten inside with a gas that's in a sealed quartz tube. These elements can get up to 3,500 degrees versus 1,800 degrees on the medium wave. So now we'll go ahead and turn it up, and we'll bring it up slowly because it does have a high inrush. So using an SCR like we are, you want to make sure you have a little bit of a delay so that you don't blow fuses. So we use high-speed fuses on the SCRs to protect them. So here you can see it's in the just maybe a quarter away, halfway, and it will get very intense, the heat. It is okay to look near it, at it, but not directly at it, just like you wouldn't look at the sun. It's not as hazardous as UV lamps are. UV lamps you don't want to look at all. You can look at these. Best not to look at them for an extended amount of time. Shut that off there. As you can see, it's an intense amount of heat in a very small area, quick heat up and cool down. Thing about these is that you can't control them with the thermocouple internal because the lamps are sealed. Best way to do it is with an infrared thermometer measuring the temperature of the material you heated. Now we're
All right, just on to medium wave lamps. Medium wave quartz tube lamps are available in clear quartz or with a gold or ceramic reflective coating that focus the emitted energy onto the surface. Medium wave lamps are excellent for surface heating and for drying coatings, paint, dyes, lacquers, adhesives, and in the processing of plastic sheet and films. The filament temperature of a medium wave emitter is from about 850 Fahrenheit to 2150 Fahrenheit. Most of the energy generated by the medium wave lamps is in the range of the electromagnetic spectrum between 2 and 4 microns. So let's talk about why you would want to choose IR heating in general versus other heating methods. So infrared heating systems are more efficient and with lower energy requirements for the same results. So energy costs can be significant, particularly today, and more companies are installing this technology to be more green. So energy is directly transferred from the heater to the target object for a higher heat transfer rate. They're available in electric or gas powered, an infinite turndown, which is very important for many applications, and are easy to fit into existing applications and equipment. Some additional characteristics include that they are easy to zone for uniform heating of the product and also for width changes, fast response to changing process conditions, including quick startup and shutdown in most styles of heaters, lower initial capital and installation costs, including floor space savings, and are often added to existing conventional dryers to increase the line speed and improve process quality. So some more applications for infrared include industrial drying of powder coating and paints, other coatings, annealings, filter media, nanofilms, battery, and fuel cell materials. And as solvent chemistries become more complex, infrared heating becomes required due to the faster response time and better control of temperature, because you really need to match that process temperature with what the product needs. And in some cases, you have to do this with infrared. So some applications here for plastic for embossing, medium wave infrared directly heats and softens the surface quickly. Water-based coating on film, medium wave infrared directly heats the surface and is the most efficient wavelength for water evaporation. Can be used with or without air. So air removes the steam and prevents the skinning effect and improves the efficiency of infrared to remove volume solvents. Infrared is also used for adhesives, impregnated fiberglass, and food applications. It's also used to improve paint quality. New coating methods require consistent high heat for proper curing. Also, metal processing. IR emitters can be precisely adjusted to the product and process. So medium wave infrared dries faster on the surface, while short wave infrared tends to penetrate deeper. High gloss metals reflect very strongly, while dark surfaces absorb the heat well, and each metal absorbs heat differently. This goes back to one of the slides we talked about before, where we need to really know all of those application details to select the right lamps and the right heating equipment for your application. The flat sheets and solid blocks heat up at different rates. And in general, they improve the energy efficiency of drying applications. So if you're not familiar with infrared heating, one of the things you want to do is get to know it a little bit before you deploy it in your application. We feel it's essential to run trials in the lab or on a pilot line to confirm dryer sizing and the desired finished product. Some coatings may not be able to take advantage of the higher rates of heat transfer and may skin and blister. They may be difficult to work with temperature sensitive substrates. And since infrared is basically a surface phenomenon, sometimes it's harder to dry heavier coatings without overheating the surface. So we offer an IR Thermal. The IR Thermal side of our business offers a rental program that allows customers to deploy infrared at a low cost to learn. And that's very important because you want to do that to fine tune your application to the product that you're working with. So here's a couple of applications of equipment that we've developed using the lamps that we supply. These are applications with T3 and twin-tuned lamps. You could see I love the picture at the bottom because it shows us in our workshop testing our product and taking some notes and making sure it's working right, which is what we do with all of our products. Here's a combination T3 lamp and hot air system. This was developed for a flexo printing interstation drying application where you print on labels for pharmaceuticals with different colors that go through different stages, therefore the interstation drying. One of the things that's interesting is that you have on the right a combination of heat in terms of the hot air and together with the lamps. That's one of the things that we specialize in for certain applications. And that goes on to our next slide of our combination and hybrid dryer characteristics. So we specialize in developing hybrid dryer processes combining the best of both worlds. Combination convection and infrared can be designed together for your application. There's another component there showed at the right that shows that. And also combination electric and gas IR. So we could develop an IR section that could be used as a booster to your existing processes. It allows for faster warm-up of the web in the process, increases the line speed of existing processes, expands the production capacity of existing equipment in the same footprint, and can improve overall process temperature consistency. So we've often used our expertise with IR lamps to solve application problems at customers. There's a couple here that I want to go over. The first one is where we solve a problem at a plastic bottle manufacturer during their annealing process. We strategically placed infrared lamps and infrared heaters that were added to eliminate cracks during bottle handling. Another application is where we preheated heavy commercial vinyl wallpaper. The infrared heaters were added to evenly heat the paper across the entire surface, greatly improving the embossing quality. And again, here's a slide on our rental heater program. We have heaters that are available in widths from 12 to 24 inches, a 240 volt or 480 volt, 1 or 3 phase. Our rental packages include the heater, the blower, and the control panel. They're designed for quick trial setup. They're plug and play. Rental terms can be as short as 1 week, and test units are available for running trials in your facility or on your line. So at this point, we've come to the end of the presentation. We'd like to ask you to contact us with your application by emailing sales@andersonthermal.com or calling us at the number below. We'd also like to take your questions now. We'd be glad to hear from you if you have any application questions for lamps. We have some experts on the line that can help you, and you can unmute and ask our expert staff on the line to see whether we can solve your application problems. So any of you guys out there have a question?
Hi, I've got a quick question. If you can hear me.
Yes, we can hear you.
Awesome. Yeah, I'm Frankie. I work at Avery Dennison. I'm an engineer here, and I was curious on the slide about absorption factor of material. Is there a specific way to test for that? Is there a specific machine that you can use, or can we send that? out to like test our material to know that our current IR oven could support maybe a different material?
Cornell, you're on mute.
Yeah, there are published tables of absorption factors for various materials. I don't think it's easily tested. It's not something we would do. Maybe in another lab they might do that. But basically, different materials have known absorption tables. So if you can consult those, then you can find out what is the product that you're heating.
It's just some PET liner with some embossable material on top. So it's kind of significant in that it's two different layers and understanding how that heat transfers to each separate layer.
So what we would usually do is heat each layer separately. Make it 2 zones in that case, and heat them separately just before they come together in the nip roll to be laminated together.
So I guess in our case, they're already together, and we're trying to just heat one layer in particular.
Okay. Well, that's something we'd probably like to take a look at in the lab and see how it works with medium wave or short wave, depending on the thickness. Short wave might be a little bit better because it penetrates more. On the other hand, if the surface is very heat sensitive, then you would want to stick with medium wave. So it's one of those things where you can look up the absorption curves for the different materials, but basically the best way to go is to test it in the lab, and we have that capability here.
All right, great, thank you.
Yeah, so if you want to send us some samples, you can contact us, and we'll run it through our lab for you.
Great, thanks for the help.
You're welcome.
Yeah, we'll reach out to you after the presentation, okay?
All right.
Does anybody else have a question?
What kind of penetration thickness does the medium wavelength IR lamps kind of get?
Well, it depends on the length of time that it's underneath the lamp. Generally speaking, it's heating the surface, but of course, the longer you keep it under the lamp through conduction, it heats through whatever it is that you're trying to heat. So if it's a thin film, you just really want to heat the surface. If it's something thicker, you might want to heat it from both sides or all 4 sides. What material are you trying to heat?
It's a carbon-based ink.
Okay.
So it's a very thin film, but it's going to absorb everything. And so I'm curious if you guys would need to be concerned about a skinning effect or anything like that if it doesn't penetrate evenly through the film.
Yeah, something like that sounds like an application for medium wave. So I would say, medium, it's probably a water-based ink, is that right?
Yep.
Yep. So yeah, the best absorption for water is medium wavelength heaters. So I think that's probably the best way to go for something like that. You don't want to overheat it. With a short wave, you probably would skin that material before you would heat it all the way through. So, again, the best thing to do is to send us some samples if you're interested, and we'll run it through the lab and see what it looks like. But generally speaking, those kinds of applications, it's medium wave.
Okay, great, thanks.
You're welcome.